Hey, today I'm gonna start to talk about the principle of moment and how we can use it for calculation of a moment. So before I start to explain how we are gonna use it, let's say how we write it. So in theory, if I want to calculate the principle, if I want to calculate the moment of any forces about any point, so it's gonna be uh, R times F. That's how I write it. So if I have a point O here and I have a example the F here, and then that's R. So the moment of that force about that point is going to be like that. Now, if I can write the force as a two components, so if I, for example, I can come here and say this F is a component, it has a F1 and F2 components. So here I put it in horizontal or vertical, but any F1 or F2. So if I have a F as its two components, and if I can write that, then it's going to be R times F1 plus F2, which in this case, F is equal to F1 plus F2. Plus F2. So I have a R cross F, and then I replace F with F1 and F2. So eventually I can say M is R cross F1 plus R cross F2. So I can write it like that. In simple word, what it says that we can either calculate the moment by using the force itself, or we can resolve the force into its component, find its component, then find the moment for each component, and then add them together. This is going to be really helpful when we are dealing with the 2D calculation later on. So what I would suggest that anytime we want to do any 2D moment calculation, it's better to resolve any forces into the X and Y component, and then find the moment for all the X component, all the Y component, and at the end add them all together. So for example, if you have a 2D, so assume it's X and Y, and the point O, and I want to find so I have a force F, and I want to find the moment of force F about point O. So let's make it a little bit. So point F, I want to find the moment of point F about point O. So the initial method that we learned was that extend the line of action, find the normal distance to line of action. So from the point, find the normal distance to the point. So it's a D, and then M about O is FT. So that's what we have done before. But generally, it's not that easy to find that distance D. To prevent doing that, what we do is we decompose that into X and Y components. So we go there and say, okay, look at here. So it's going to be our Fx, and it's going to be our Fy. And the distance it has it to the X and Y. So here, the distance it has it, if I extend this line here, this is going to be, assume it's going to be D in Y direction, and then so it's going to be D in X direction. So what I would do that, so I will find the moment for each component, and then add them all together. Here, so assume that I consider, let's put a sign here. So if I consider counterclockwise positive, so this is going to be negative, because assume I connected rope from here to the point, so it's going to rotate it clockwise respect to the O. If I connect a rope from O to point, hold that end, and let's see which direction rotate this way, so it's going to be negative. So I'm going to put the negative sign here. Now in the second method that we want to find the moment about O, but by using its component. So I will start with fx. So if I look at the fx respect to the O, it's going to rotate it clockwise. So it's going to be negative because we consider counterclockwise positive. And so it's going to be negative. And the value of fx and the distance it has, the normal distance it has to the point O. So the normal distance is dy. And then we go for the fy. If I look at the fy compared to the O, it's rotating counterclockwise, so it's positive. It's magnitude of the force, and the normal distance from the force, to that point, which is going to be dx. So you do the calculation like that. Doing it like that, it helps us not to look for the d and try to find the d. So in this case, we don't need to find that normal. So just working on this simple x and y coordinate, and helps us to calculate the moment much easier. Later on, when we are working with the 2D problems, it's much easier to do it like that. So first, go for any force we have, find its x and y component, and then find the moment for each of those components, and then add them all together, and that's your moment. Now let's look at an example to how we can resolve a force on the x and y component and find the moment. So assume we are asked to find the moment of that 100 Newton force that acts on this object about the point O, which is here. So we want to find m about point O. As said, is in 2D, the easiest way of doing that is to go ahead and find the component of that force. So the x component of that force is going to be 100 cosine 30, and its y component is going to be 100 sine 30. So it's the y component and x component, and then we will calculate for the m. First we considered, okay, that's our positive for the moment. So m about O is, we start with the x in the direction of x. So the force is, so look at the force. If I consider that force, the 100 is rotating clockwise. So if I connect the rope from here to the force and see which direction it rotates clockwise, so it's going to be 100, and the magnitude of force is 100 cosine 30. And the normal distance from the force here is that we'll extend the line of action for that force. So we extend that line of action, and then it's the d1, which is going to be 4. So the normal distance for this force with respect to the point A is 4. So it's times 4. And then we write it for the y component. It's going to be, look at that, respect to the point O, again it's rotating it clockwise, so it's going to be negative. The magnitude of the force is 100 sine 30, and then again the normal distance that we extend the line of action, and then that's the distance, the normal distance respect to point O. So it's going to be 1. Times 1, and if we do the calculation, we're going to get 396 396.41 Newton per meter, which indicates that this negative means that the rotation is the clockwise, and that's the magnitude of the moment. If you see, you can see here, it's much easier to find the x and y component and then find the moment for each component, and at the end just add them together and get the moment of that force respect to or about to any point, rather than directly calculate that force and calculate the distance from the force to that point.